Thanks everyone for staying with us. I hope you've enjoyed the conference so far. And now we're ready for the last, I don't know what to call this, the last show, session, plenary. Well, we'll see as we get underway. It's my pleasure to introduce to you all Peter WRIGHT, who's here with us. To be honest, it nearly wasn't my pleasure to introduce Peter WRIGHT, as we did have a number of issues when he told us he was going to have some explosions, some bombs, some rockets, and we had to buy bottles of propane gas. But luckily, it does all seem to have been sorted out. And if you do see the conference team standing by the doors, that's just pure coincidence, okay? It's honestly really, really safe, nothing to worry about. But we'll all be standing over there. Peter is the director of Wonderstruck, and he has been designing education resources for a wide range of institutions and performing educational shows such as this for a long time. Before that, and I think from what I've heard, possibly still at times, and amongst other things, wait for this list, he has been a poet, a parachutist, an engineer. He's made parts for nuclear submarines and office chairs. He's taught physics to A-level students. He's traveled Asia and the Middle East investigating contact between the Mongols and the Crusaders. He's also apparently found time to get a master's degree in education and educational management. So if you think you are a high achiever, you're not anything yet, really, are you? Yeah. Today, he says we are going to see him attempt to propel himself across the stage with a homemade rocket pack. I'm not sure if that's happening in the end or not. He's going to detonate a desktop thermobaric bomb. I have no idea what a thermobaric bomb is, it must be said, but I've been told that casualties should be light. Okay, so we'll see. He also says that we'll leave with a basic understanding of forces, pressure and motion, and an idea of how to use science to engage a school audience. So I think this is going to be very exciting. One little warning, there are a couple of moments when we're going to hear some explosiones, ruidos, no? Y en estos momentos, he's going to say the same in English, but just in case somebody doesn't get it, no? En estos momentos hay que tapar los oídos, no? Okay? Él nos va a indicar cuándo, pero cuando él hace esto, todo el mundo lo mismo, okay? Because our insurance doesn't cover this. Okay, so with that, I'm going to stop talking, and we'll let Peter take over. So this is Peter WRIGHT and Ultimate Force. Thank you, Peter.
Thank you. Oh, I don't need that. Buenas tardes. I'm afraid that's it for my Spanish, apart from hola. So the rest of the show is in English. And what a fantastic introduction. I don't normally get introduced like that. It's very nice. So the show, what the show is going to be about is it's shorter than shows we normally do. We normally do about an hour. So we've just distilled a few pieces. There were some bits where there was some kind of incompatibility between Spanish and English gas fittings. So we've had to change a few little things along the way, but we got there in the end. To start with, there will be, hopefully, a loud bang in the show. I will tell you when the loud bang is going to happen, and I will ask people to cover their ears for that. If we've got the gas mixture just right, it's very important that you cover your ears for that, because the resulting bang, if you don't, could lead to hearing damage. So I will check as far as I can that everyone has their ears covered when we get to that point. So, the show, obviously a science show. It's a collection of demonstrations fit to a kind of theme with the entire purpose of inspiring the audience to think, that was interesting, I'm going to go out and learn a bit more about that. So that's what we're about, that's what we do. We go into schools and we try to infuse and engage students of all ages and adults as well. So hopefully at least some of you will go away from here thinking, that was interesting, maybe I'll become a science teacher instead of an English teacher. Or maybe you'll see some things which you think, I could use some of those in my lessons, like the little session I did this morning was all about that. So let's get started. So first of all, science. Science, when we're doing practical demonstrations, the first thing is safety. We have to be very conscious of safety. And the show you're going to see is going to involve some fire, so we have to be very careful when we deal with fire. And one of the things, here's actually some fire that I brought with me. It's burning quite, you can actually see, yeah, there's a flame there. So you can see that's burning, and one of the things you should obviously never do, you should never touch fire. So what you shouldn't ever do is that. because fire's hot and it's obviously going to burn you. Now, I was able to do that because I understand a bit about the science of how that's happening, of what's going on when something burns. So when something burns, most of the heat goes upwards. So if I put my hand above that, again, within a second, I'd have a serious burn and be off to hospital. So I was careful to keep my hands underneath it. It's soaked in a liquid which burns at quite a low temperature. It's still plenty hot enough to burn you, but nowhere near as hot as something like petrol. I was also juggling it from hand to hand, so the heat didn't get a chance to build up in any one place. And also, the ball is made from cotton. It's a natural material, so when it burns, it chars. It goes black and crumbly. It doesn't melt like synthetic materials, like nylon. If I did that with nylon, the plastic would melt, stick to my hand, and I'd be off to hospital. So understanding the science allows you to do a little interesting demonstration. Now, you know, if you want to try that kind of thing, be very, very careful and make sure you understand fully what you're doing. I've seen people try to do it in a classroom surrounded by books and paper. The ball actually burned them and then going, ah, and then the ball disappears down the back of a cupboard where there's all exercise books. So you've got to be very careful. But science is also about finding out how things work. It's about curiosity and creativity. So what I've got here, it looks like a bin, and quite often at the end of a show, if I put it down by the side of the stage, I find it full of sweet wrappers and ice cream cones and things like that. But it isn't. Well, it was, but it's not now. As you see, this bin has a hole in the bottom, like this. And on the back, I've put a baggy piece of polythene. These are very easy to make. You can try this yourself if you want to. You can do it with a cardboard box or any kind of container. You just need one side open, one side with a hole in it, and a piece of baggy polythene on here. But if I do this, I have to be very athletic to do this. Did anyone feel that? No, it's quite difficult to aim these things. Yeah, you can feel that. Yeah, anyone feel that? Well, some of you on the front row can probably feel that, but you can't see it. Now, some people are experiencing there a gust of air, which is a bit odd. Now, with one of these, if you can aim it properly, you can actually feel the gust of air probably at the end of this hall, which is really strange, because if I had a desk fan here and I point it at the end of the hall, it's highly unlikely you'd be able to feel it. If I stand here and blow like that, you couldn't feel that, could you? No. It's a good job, actually, because I had all those pastries, so there's probably little bits of pastry. You might want to wash your hair when you get home. But with this, there's something different happening. But we can't actually figure out what it is without doing something different, because we can't see air. We can't see what the air is doing. So what I've got down here is a little smoke machine, and I'm going to put some smoke inside, and hopefully we'll see what's happening. So now, if I get into my athletic position, there we are. So this is doing something quite interesting. It's producing a vortex or smoke ring. And now the next question is, we know what it's doing, so the next question is why? What's happening? And by looking at the design of this, you can figure it out. Because when I hit the back here, like that, it pushes air forward. It acts like a piston. And the air comes out through this hole. So it goes forward, but some of the air doesn't. Some of the air is pushed backwards, some of it's slowed down by contact with the side of the bin, and as it comes out around here, it folds around itself and forms a vortex. It forms a smoke ring. And that structure is kind of self-sustaining, so it carries on. It will travel to the end of the room until it gradually loses its energy to the air around it. So this is a little project you could try at home. Don't need a big bin like this, but and a smoke machine, you don't need that. It just makes it more visible. Just get a stack of paper cups and you can knock them over. So quite an interesting thing. Now, I said we're going to have a bit more fire. So what I've got here is something quite interesting as well. Now, normally I use lighter fluid, with this because you can see the flame quite clearly, but we're using a bit of salt and some ethanol in here, so I'm just going to pop a bit of that in there. The salt is in there because when salt burns, it gives a nice orange colour, so it makes the flame a bit more visible. So now, I've set that on fire. You might be able to see, yeah, the flame's a little bit yellow, that's quite nice. And I'm going to pop this over the top, like so. And give it a spin. If you're into photography, you can get some quite beautiful pictures of flames doing this. But the question is, why does it do it at all? Because when I stop the spinning, you just get a burning tin of liquid. So again, we have to use our kind of reasoning to figure out what's going on. And what turns out to be happening is as I spin this, you see this wire mesh, the air is getting caught in the wire mesh and it's getting turned around. The air itself is being turned in a vortex, a kind of tornado shape. But we can't see the air, but we can see the flame. And the flame is being pulled up by the twisting air and we get that lovely kind of vortex effect. So there we go, another little demonstration. Just leave that on there for a second. Now, ever since I was very, very small, the reason I got into all this kind of stuff is because I've been fascinated by rockets. I don't know why, but ever since I was very small, I love things which caught fire, things which move really fast and occasionally explode. So rockets fit the bill. So I thought what I'd do is the rest of the show kind of theme it around rockets and pressure. So I thought to start that kind of section of the show off, I would bring a super high-tech rocket with me. The kind of rocket that's going to take people to Mars in the next 30, 40 years or so. Now, at certain points in the show, it becomes a bit like a pantomime. I'm not sure, do you have pantomimes in Spain? I don't know, but in England we do at Christmas time and there's lots of audience interaction. So if I ask a question like, who would like to see the rocket? What I don't expect is everyone to go, okay, it needs to be a bit noisier to persuade me that you actually want to see it. So who would want to see the rocket? Me. That really isn't loud enough, you don't sound very enthusiastic. So who would like to see the rocket? Me. I have heard 6-year-olds make more noise than that. So, last chance, who wants to see the rocket? Me! Right, that's a bit better. Now, I've just got to remember where I actually put it. Oh, here we go. There we are. Are you impressed? Yes? No? I did hear some people say yes or see. Yes, I'm impressed by that. Which is quite refreshing because in the age of Xbox One and PS4 and all that kind of stuff, it's nice to know there are still people who are impressed by a small plastic bottle. That's quite good. Now, actually, this, it is a rocket, but it's not going to get you to Mars. If you walk down the street with this and someone said, what are you doing with that? And you said, I'm going to go to Mars on this, they think you're a bit odd. It's not going to get you to Mars because it's too small. But it does work in exactly the same way as a real rocket. Because what I'm going to do is I am going to put a bit of rocket fuel in here. I'm going to put on some safety goggles. They're quite trendy, aren't they, for safety goggles? Never used to have them like this when I was at school, but these are safety goggles. Now, I'm going to put some rocket fuel in here. Now, I only need a very small amount. There's only about 1/3 of a teaspoon in there. Now, this is not because this is very powerful rocket fuel. It's not powerful rocket fuel. It's quite weak in terms of rocket fuel. It's a type of alcohol. Now, I don't normally say this to my audiences because they're generally children, but you can do this with vodka. But obviously, if you say that I told you to do it with vodka in a class, I will deny all knowledge. So I'm giving it a shake. Now, the reason I only need a very small amount in there is when we burn something, we actually need 3 things. We need the fuel, which I've just put in. We need an energy source to ignite it. And we need one other thing. Does anyone know what the other thing is? Yeah, shout it out if you know. Some people say air, some people say oxygen. It's actually oxygen. Air is a mixture of gases, one of which is is oxygen. But if I split up the gases in this bottle, there's actually only about that much oxygen. Oxygen makes up about 1/5 of the air that you're breathing at the moment. The rest of it, about 80% nearly, is nitrogen, a little bit of carbon dioxide and a few other gases. They don't take part in the burning, it's just the oxygen. So once the oxygen has used up that fuel, or the fuel has used up the oxygen, if there's fuel left, it can't burn because there's no oxygen left for it to burn with. So we only put a small amount in to burn with that amount of oxygen. So let's pop that on here. Hopefully this is going to go well because it's a nice warm room. Right, so it's a rocket, and whenever we launch a rocket, we have to have a countdown, and it has to be loud. So are you ready? 5, 4, 3, 2, 1. There we go. Now, would you like to see a slightly larger one? Remember what I said about the pantomimes? Would you like to see a slightly larger one? Yeah! Okay, that's better. Right, let's see if I can find the slightly bigger one. Here we go. Right, so that one was 1/2 litre. This one's 1 litre. So we need twice as much rocket fuel. There we go. So twice as much rocket fuel because we've got twice as much volume, twice as much air, twice as much oxygen. There we go, that should do it. Always remember to put the top back on the bottle, so we don't want to set fire to the bottle full of rocket fuel. So give it a good shake. We're shaking it because we want lots of vapour, because it's the vapour that burns. That's the particles of liquid that have got enough energy to actually escape from the liquid itself and become basically a gas. So they can mix with oxygen and burn very efficiently. Right, so there we go, slightly bigger rocket. So it's a bigger rocket, we need a louder countdown. So you ready? 5, 4, 3, 2, 1. There we go. Now, they're quite good. They're quite impressive, but they don't really do anything useful. They shoot across the room, but, you know, great. So I thought what I would do is I would actually apply the same principle to something a bit bigger and a bit more useful. Would you like to see it? Yes! Yes! Okay, that's good enough. Right, here it is. First one was 1/2 litre, second one was 1 litre. This is 20 litres. This also has shoulder straps. Now, unfortunately for me, and this is true, because of insurance reasons, I'm the only person allowed to wear it. Because it's considered, don't know why, a little bit dangerous. Now, what I'm going to do is I'm going to put some rocket fuel in here. I'm going to ignite the rocket fuel. If my calculations are correct, I should lift off the stage and soar majestically through the air. If there's enough fuel in here, I may do a loop above the audience and I'll come and land somewhere like that. Okay, that's the plan. Now, this is a very kind of primitive prototype, so it doesn't actually have its own ignition system. I'm going to need a volunteer to light the rocket pack for me. So if you fancy lighting a rocket pack, I'm afraid it does need to be an adult. I can tell you two are absolutely desperate. So do I have an adult volunteer? Did you volunteer? Excellent, right. Come on up. I think, yeah, your hair's safe. I'm not sure about mine. Right, okay. What's your name?
Rosie.
Rosie, right. Okay, Rosie, what's going to happen? I'm going to stand here.
Okay.
Just pop that there. You'll see why we've got that in just a minute. So I'm going to stand there. So imagine this is on my back.
Okay.
What I'm going to want you to do, lighter. Now, at arm's length, keeping as far back from it as possible, I want you to light the lighter and then put the flame just into the neck of the bottle there.
Okay.
Okay, but whatever you do, don't put your hands behind it.
Right.
Because it's a rocket. Okay?
Okay.
Excellent. So hand to the side, arm's length. I am going to give you some safety goggles. Equally trendy. There we go. Are you okay to see
Yes,
what you're
yes,
doing?
yes, I am.
Okay, that's quite important. Oh, and one last thing. Sometimes, this is where the fire extinguisher comes in. Sometimes, if I put a little bit too much rocket fuel in, it drips out and sets me on fire. If that happens, if you could just pat the flames out.
Okay.
Okay, good.
Can I get something, or do I have to use?
Just use your hand, that's
Okay.
fine, that's fine. If the flames are too big to pat out, I will probably roll on the floor,
Okay.
at which point you need to pick this up,
All right.
pull that pin out, point that at the bits of me that are on fire,
Okay.
and do try to,
got you. I've got you.
put them out. Right, okay, let's put that there. Okay, right, now I'm going to wear my trendy goggles. Let's put the fuel in. 1, 2, 3, 4. I've put on a few pounds. 5. That should do it. Right, so here we go. You nervous?
No.
I am. Right, okay, there is rocket fuel dripping out the back, but hopefully that will be okay.
Okay.
You've got that. And remember, pat the flames out, or at least tell me I'm on fire. Right, so arm's length, hand well to the side.
Get on this side then.
Yeah, if you can get on that side, yeah. That's it, okay, you ready? We're going to do a countdown.
Okay.
Yeah. Right, okay, we ready? 5, 4, 3, 2, 1. Am I on fire? No?
You're on fire. It just
Excellent.
pushed.
Right, oh, okay. But I didn't lift off. Oh, maybe back to the drawing board with that one
Not
then.
enough rocket fuel.
Maybe not. But anyway, can we have a big round of applause for Rosie there? Thank you very much.
But it was amazing, though.
Thank you. Now, my rocket didn't work. Are you surprised? For a rocket or anything to lift you off the ground, it has to produce a greater force upwards than the force that pulls you downwards. So what's the force that pulls us downwards? Gravity. Gravity pulling on our mass, the stuff we're made from, gives us weight. So my rocket needs to produce a thrust, that's what we call the force a rocket or a jet engine produces, a thrust upwards which is greater than my weight for it to lift me off the ground. And although I have been trying to be on a diet, this obviously is not overcoming my weight, so it's not lifting me off the ground. If I wanted this to lift me off the ground, there are a number of things I could do. I could increase the thrust by using different propellants. Now, the problem is this is a plastic bottle. It will only withstand a very low temperature for a very short period of time. So I'd have to make it all out of metal. It would be very complicated and much too dangerous to actually use in a show. But ultimately, what it comes down to is increasing the pressure inside the combustion chamber. The combustion chamber is just where the burning happens. So pressure is quite an interesting thing in its own right. Anyone here like a bit of maths? It's a stupid question to ask an audience which is predominantly English teachers. But anyway, if you do and you're just too embarrassed to put your hand up, pressure is very easy to work out. It's the force divided by the area that it's pushing on. So it's really just a measure of how force pushes on an area. So if I increase the pressure in here, it's pushing the gas out with more force. And there's a law of physics called Newton's third law of motion, which says if you push something in one direction, it pushes back on you in the other direction with the same force, basically. A bit more complicated than that, but that's the basics. So if I can push the gas out of here with more force, with increased pressure in here, the gas is going to push back on the rocket with more force and hopefully eventually lift me off the ground. So pressure is force divided by area. Now, I can illustrate that with a little demonstration. Imagine I'm walking down the street. This is how we walk down the street in England. This. I go backwards a little bit. Like that. So it looks cool. Takes me ages to get anywhere, though. So I'm walking down the street. Maybe I'm even listening to my iPod. Bit of Harry Styles, One Direction. They big in Spain? I don't know. Maybe I'm listening to him. Well, yeah, there's not many of them left, is there? I don't know. But what I don't notice is someone has left a piece of wood with a 4-inch nail banged through it on the floor. So I'm walking along, don't see it. Lots of Harry Styles. Ooh! Now, I didn't do that. For those of you at the back, I didn't actually stand on the nail. But if I had done that, the nail would have gone through my foot. Now, the reason the nail goes through my foot is because there is a lot of pressure. Remember, pressure is force divided by area. So the force pushing down is my weight, quite a large number. The area that it's pressing on is just the tip of the nail. The area of the tip of the nail is a tiny number, much less than 1. So we have a large number divided by a tiny, tiny number, much less than 1. So the answer is an even bigger number, and that's the pressure. The pressure is huge. If there were 2 nails here, the same force is spread over twice as much area, so the pressure is half as much. If there are 4 nails, same force spread over 4 times as much area, the pressure is a quarter as much. Every time I add some nails, I reduce the pressure from each individual nail. So I was wondering, how many nails would I need before the pressure from each individual nail was low enough that it wouldn't push through my body? So I did some calculations, and I worked it out to be around about 1,000 nails. So I spent a very enjoyable evening banging 1,000 nails through a piece of wood to produce the Wonderstruck Bed of Doom. Now, what I'm going to do for your delectation and delight is I'm going to lay on the bed of nails. Now, once again, for insurance purposes, I have to lay on the bed of nails. But not only am I going to lay on the bed of nails, I'm going to make it a bit more interesting, because what I'm going to do is I'm also going to have a small bed of nails on top of me, like that. Now, do you think that's enough? No? You're a rotten audience. Right, okay, so not only am I going to lay on the big bed of nails with the small bed of nails on top, but let's make it a bit more interesting. Let's also put a couple of bricks on there just to make it a little bit heavier. Okay, actually I'm going to put a piece of wood on there just to protect my paintwork. Very, very particular. So pop that on there like that. So we're going to put the bricks on there like that. And I think, let's make it a bit more interesting. Not only am I going to lay on the big bed of nails with the small bed of nails on top of me and the 2 bricks, but I'm also going to put on top of that a concrete block. Now, we had to travel back on the metro with this from a long way away. So that's going to go on top there, like so. Now, not only am I going to lay on the big bed of nails with the small bed of nails on top, the 2 bricks and the concrete block, but we're going to smash the concrete block with the mighty sledgehammer. So there we go, that's what I'm going to do. Now, I need a brave volunteer to actually do the smashing, because, and it has to be someone over the age of 18. I'm not trusting anyone under the age of 18 swinging a sledgehammer that close to my head. This chap here. Excellent. And what's your name?
Carlos.
Carlos. Okay, right. Carlos, what I'm going to do is I'm going to lay on the bed of nails. If you could then put these things on top of me one by one, okay. And then we'll do a countdown, 5, 4, 3, 2, 1, and if you just smash the block in the corner.
Smash the block?
Smash the block. I'm going to give you some safety goggles, just to stop, bits flying in your eye. I'm going to wear this, so I don't want it hitting me in the face, although this isn't particularly sturdy. Now, to be honest, I'm just thinking the time is getting on. And those nails are looking a bit sharp. I don't know whether to move on to the next demonstration, actually. You don't really want to see this, do you? Yes! What, yes, you don't want to see it? Well, no, you don't want to see it. You do want to see it, right. Excellent, that's always nice to know. Right, okay, here we go then. Oh, I think one just went in me. Oh.
Ready, babe?
It is, yes. Right, okay. So, if we could have the small bed of nails first, or you can put it all on at once, but please don't drop it. Is it? Yeah, take this off first, yeah. I think so, yeah. I'd rather not have it dropped on me. Okay.
Okay.
Whoa.
Yeah?
Yeah, that's good. Move that up there. Oh,
Are you sure?
not really.
Here.
Hit, yeah, right in the middle. Okay, right, so, are we ready?
No.
Well, I don't know what you're worried about. Okay, so we're going to do a countdown. 5, 4, 3, 2, 1. Oh!
Are you okay?
Yeah, that's fine. Oh, excellent. Thank you very much. Oh. Oh, and there we go.
I'm really sorry.
Yeah, no, it's fine. It's fine. Thank you. We have a big round of applause for Carlos. Thank you very much. Thank you, Carlos.
Clean the mess.
No, that's fine. That's fine. Can I have my goggles back, though? Thank you. Right, excellent. And I do appear to be completely unharmed. Now, I won't know for sure until I have a drink of water or something slightly later and see if any sprays out. Now, I said we were talking about rockets. Now, the original rockets were invented by someone in China over 1,000 years ago, and they used gunpowder as the propellant. Now, gunpowder is what we call a solid rocket propellant because it's a solid. But the special thing about gunpowder is that it contains oxygen, even though it's a solid. Up until the invention or discovery of gunpowder, whenever we burn something, we're burning something using oxygen from the air around us. So a piece of wood will burn quite nicely in your fireplace or wherever at home, but if you take it into space, it won't burn because there's no oxygen. If you take it underwater, it won't burn because there's no oxygen. But gunpowder is a mixture of charcoal, which is the fuel, a little bit of sulfur just to make it easier to light, and potassium nitrate. And potassium nitrate is a white powder, it's a solid, but the molecule contains lots of oxygen. And that's what supplies the oxygen for the charcoal to burn. And it burns very, very quickly. Now, in the UK, in the shows in the UK, I have an explosives license, so we use gunpowder. But unfortunately, I'm not allowed to ship gunpowder overseas. Who knows why? So we can't do that today. But solid propellant rockets were the only type of rocket until the 1920s, when an American guy called Robert Hutchins Goddard wondered if he could build a rocket that used liquid propellants. So he built a rocket which used kerosene as the fuel, paraffin, and liquid oxygen to supply the oxygen that the kerosene needed to burn. And he found his rocket worked very well. And the advantage was he could switch it on and off all the time. Whereas a solid propellant rocket, once you've lit it, carries on burning. You can't stop it because it contains its own oxygen and you can't put it out. So a liquid propellant rocket, you can switch on and off. Now, the key thing with his rocket was the propellants, the liquid oxygen and the kerosene, were sprayed together. Now, when you have a chemical reaction, there are a number of ways you can speed it up. And one of them is increase the surface area of the chemicals that are reacting. And by spraying two chemicals together, you're doing that. Because instead of like one block, if you like, of chemical, you've got lots of tiny, tiny little ones, all with a relatively large surface area. So the reaction can happen much more efficiently and much more quickly. So what I want to do now is just demonstrate the difference between burning a liquid in a container and burning it as a fine spray. Now, the liquid I'm going to burn, I'm going to do this down here because we need a little bit of head height for this, and I looked at that lovely wooden ceiling and thought, so we'll probably do this a fairly small one. But the liquid I'm going to use is actually a solid at the moment. It's a wax. Now, I'm going to have to heat it up, and when I heat it up, it's going to turn into an oil, and the oil will catch fire. But in this container, which is about the size of an egg cup, in this container we'll have a flame maybe that tall, because it's only the surface of the liquid that can mix with oxygen, or it's actually the vapour above the surface that mixes with oxygen and burns. All of the liquid underneath the surface can't burn because it can't mix with oxygen. Now I'm going to change the conditions by turning it into a spray, and I'm going to do that by shooting water into it. Now when I shoot water in, the water is heavier than the oil, so it sinks underneath. This container will be 400 or 500 degrees, so the water is going to turn to steam very, very quickly. It's going to flash boil. So the water that gets under here, when it turns to steam, it expands in volume about 2,000 times. And that expansion is going to shoot the wax out in a fine spray. So suddenly all of that wax can mix with oxygen in the air, and it's all oil, and it's all going to burn in half a second. And we will see something slightly more dramatic. Now it is quite dramatic, and for that reason I'm going to ask if you three people here could maybe just go and stand here for this one, and if you three people here could maybe just stand over there for a second, and I think probably if we have the second row as well, so if you three and you, you three on the end there, if you want to stand over that side, just in case. Right, so let's pop my little crucible in there. Oh no, you'll be fine there. Well, right, I'm not going to do this too big because we've got quite a low ceiling. I'm going to put a visor on because sometimes it spits a little bit. Like so. Try and light my blowtorch. There we go. Right. So this is just going to take a minute or so just to melt everything down. And we want to get it really nice and hot. And we've got to make sure all that solid has turned to oil. So it doesn't take long, nearly there. You can see the crucible at the back is starting to glow red. So it shouldn't take too long. And you can see the top is, you can see a flame on the top now. But it's not exactly anything to write home about. It's not very dramatic. So I'll pop that underneath. And nearly there. Make sure it's really, really hot. Should do it. Right, so another quick countdown. You ready? 5, 4, 3, 2, 1. There we are. Now, this experiment has a bit of a disadvantage. It's quite dramatic. You people can come and sit back down now. It's fine. Just, obviously don't touch that because it's very hot. So if you want to come and sit back, take your seats again, that's fine. Now, this experiment does have a little bit of a disadvantage for me because I'm quite close to it. What happens is the oil shoots out and most of it burns, but some of it doesn't. So some of it comes back down and it lands in my hair. Now, as you've probably noticed, I've got lovely hair. Who noticed that? Excellent. A few people did. That's nice to know. Normally when I do this in schools, I get a very mixed reaction to that. So some of it lands in my hair, and as the oil turns back into wax, it forms little droplets of wax in my hair. And I can't get this out. It won't come out with normal shampoo. So I've had to invent my very own shampoo, which I call flammable gas shampoo. You might be able to see where this is going. Now I'm going to have to do this quite quickly because we've got my lovely rich shampoo lather over there. And all I need now, and you need to listen to this sentence because you'll probably never hear it again unless you come to another one of my shows, and that's that I need a sensible volunteer to set fire to my head. Do I have a sensible... Actually, yes, we can have a young chap come and do this. Right, excellent. And what's your name?
Robert.
Robert, right, okay, Robert, mind that bed of nails. I'm going to give you this, and I'm going to give you those. Right, so practice lighting that. Don't upstage me. There we go, that's good. Now I'm going to put the bubbles in my hair, and then what I want you to do is light the lighter, and then put the flame into the bubbles. Okay, not into my ear or anything like that. Yeah? Right, so I'm just going to put some luxury conditioner on. There we go. Actually, do you think my hair looks good slicked back? Yeah? Or should I leave it like that? Excellent. Right, so let's actually, Robert, if you come over here, this will probably be easier. I'm just going to put some bubbles on.
Not so much.
There we go. Let's pop a bit on there. Oh. And a bit on there. I think that's probably all we've got because we had to rush them from the lab. So, okay, so if you light that and stick it into the bubbles. So in your own time, light it first. And in the bubbles. Did it go? Yeah, you can stop now. Excellent. Can we have a big round of applause for Robert, please? Can I have my goggles back? Thank you very much. Right, okay, I think we've got time for 2 more demonstrations. I think we've kind of overrun a bit anyway, so it's nice to see that a lot of you have stayed. So, rockets. Now, when we send a rocket into space, they use, or the big rockets that send satellites up, will either use, on the first stage, paraffin as the fuel and liquid oxygen to supply the oxygen, or sometimes liquid hydrogen as the fuel and liquid oxygen to supply the oxygen it needs to burn. Now, when we do these shows in the UK, we use, for the next demonstration, a balloon filled with a mixture of hydrogen and oxygen, just to illustrate how much energy is released when you burn a very small quantity of these things. I'm not allowed to carry the liquid forms of those chemicals around, it's much too dangerous. We haven't got hydrogen here, so what we've got instead, we've got a balloon with a mixture of methane and oxygen in it. Now, methane is the gas, if you have a gas cooker at home, if it runs off mains gas rather than a bottle, it's probably using methane. Now, methane burns with quite a nice flame. It's good for cooking and stuff like that. It burns in air relatively slowly. But when you mix it with oxygen, it will burn much more efficiently. So what I've got back here, hopefully if it hasn't gone down, I have got probably the most dangerous balloon in Madrid. Here it is. Now, if we've got the mixture right, and the what we call the stoichiometric mixture, that's the kind of most efficient mixture for combustion, we'd have 1 part methane and 2 parts oxygen. So all of the methane can burn with all of the oxygen. And when we burn this, we get water vapour and a bit of carbon dioxide given off. So what I'm going to do is I am going to set this off. Like I say, if the mixture is just right, it will burn very quickly. And when it burns very quickly, it's going to produce a very loud bang. Now I'm going to say all this in a minute, and the mixture will be just slightly off, and it will just go bong, like that. But we have to be safe. So we're going to assume that this is perfect, and I'm sure it will be. So this is where I'm going to need everyone to have their ears covered, because this potentially is very, very loud. So I will need everyone in here to cover their ears. Now I'm going to wear these because I've got to set the thing off. And when you cover your ears, so when we deal with kids, quite often they put their fingers in their ears. And that is completely the wrong thing to do. If you put your fingers in your ears, if the bang makes you jump, you can actually push your finger far enough in to burst your own eardrum. And the other thing is, of course, when you take your fingers out again, if you put them in your mouth, they taste disgusting. So you always use the flats of your hands. So, could I now have everybody in here with their ears covered? Okay, I need you to check your neighbours, make sure you have your ears covered. Okay, I will look and see. If I see anyone who hasn't got their ears covered, I am going to have to ask them to step out. Yeah, Mr. Photographer, yeah, I'd have to ask you to cover your ears for this, I'm afraid. Just in case, we can't be too safe. Right, so I'm going to light this with my flaming stick. There we go. Right, so let's try this. Okay, ready? 5, 4, 3, 2, 1. Never mind. You can just have to imagine that was an incredibly loud bang. Now, as you can see, science doesn't always work. It's usually, down to us. But rockets, lifting something off the ground with a rocket is actually a very technical thing to do. And the main problem is guidance. It's actually controlling the rocket because rockets move very quickly. So if they start to go off course, you've got to correct for that very quickly. So the control systems have to be quite complicated. So I was thinking it might actually be easier to build a rocket which propelled something along the ground rather than up into the air. So what I've got here for the final demonstration is the Wonderstruck Rocket Car. So it's under wraps, it's all top secret. Would you like to see it? Yes! Are you sure? Yes! Right, let's just pull it back a bit. I think it's caught on something. Let's try. That's fine, lovely. Thank you. Right, I think if I've got rather an oversized tarpaulin. There we go. Right, I think we need a bit of a drum roll. Ready? Yes, excellent. Someone's getting into the mood there. There we go, and ta-da! Now, this rocket car, all the rockets that we've talked about so far have actually involved burning stuff. Now, this rocket car works slightly differently because the main power is supplied by a CO2 fire extinguisher. Now, CO2 fire extinguisher actually contains liquid carbon dioxide. The pressure in there is about 50 bar. That's 50 times atmospheric pressure. So there's a lot of pressure in there. When we open the valve at the top, that pressure can escape. The pressurized carbon dioxide comes out through the nozzle at the back. And remember, Newton's third law of motion says if you push something that way, it pushes you that way. So hopefully, we've had a problem with our fire extinguisher. It's been leaking all day, so I'm not sure how much pressure's left in it, but we'll give it a go. So what I'm going to do, just to finish off, I will come back in, but we're going to open those doors, and I'm going to use the car to disappear out through the doors. Okay, right. Now I need to make sure, I've got a few little safety checks to do first. Just need to pressurize. We've got a pneumatic system which opens the valve of the CO2 cylinder, and then we've got a sophisticated electronics system to actually set it off. There we go, there's enough pressure in there. Right, so I think we're okay. We seem to be kind of lined up with the door, like that. Let's open that. Switch on and climb on board. So hopefully this will be a bit more successful than my my balloon. Right, so here we go. Yeah, give me a countdown, why not? 5, 4, 3, 2, 1. Yeah, I think our cylinder leaked a bit too much. Oh, well, never mind. Well, that was supposed to be my dramatic exit. So it's a bit of a shame, but never mind. Anyway, I very much hope you enjoyed the show. We're actually, this is our first time in Spain, but we're very keen to kind of look at new, exciting places to do our shows and workshops and stuff like that. I think you all had a flyer on your seat when you came in. If you're interested, drop us an email, because we are looking at coming back into Spain for a couple of weeks or so, where we all go around schools in the Madrid area and do workshops and shows and stuff like that. So anyway, thank you very much. You've been a wonderful audience. I hope you had a wonderful conference. Thank you.
Thanks very much. Thanks very much, Peter. That's Peter Wright. And thank you all for staying till the end. Couple of very, very quick things. Certificates on your way out. They'll be there if you want to pick them up. Feedback, we'll be sending it to you via email. Okay? Please do give us the feedback, because we need it and we like it and we use it to change things for next year. If you don't give us the feedback online, next year we'll go back to paper again and make you do it before you leave, so it's up to you. But if you can do it, then that would be great, yeah? Just thank you to everybody who's organised everything, the organising teams, the speakers, to Peter, to Gail, and to all the people involved, anybody who's watched online as well. And we'll see you all next year, unless we see you earlier doing one of our CLIL courses or something. Thanks very much. All right.